In a previous video, we looked at mechanisms and arrow pushing. In this video, I'd like to look at some examples of the types of problems that we might ask for this section. So as a way of a quick review, there are 4 mechanism patterns that we want to be on the lookout for. In nucleophilic attack, a nucleophile attacks an electrophile, and we're making a bond. Right? We formed a bond between this oxygen and carbon. In the second pattern, we're looking for a loss of a leaving group, right? And very simply, if a group pops off, as in this case the chlorine does, right, then we have the loss of a leaving group. The third pattern we look for is proton transfer, right? And my summary of that is a proton is transferred. And then finally, carbocation rearrangement. If we have a methyl or a hydrogen trading places with a carbocation, then we have a carbocation rearrangement. All right, so one type of problem that we might be asked is to identify what pattern it is we're observing in a particular step of a mechanism. Right, so in this case, I've got a bond becoming a lone pair on this group, right, and that group is popping off. So this would be an example of losing a leaving group. All right, in this example, I'm making a new bond, right, and I have an electrophile being attacked by the lone pair from a nucleophile, and so this would be an example of nucleophilic attack. All right, in this case, I have a carbocation, and it moves, right? It traded places with this methyl group, so this is carbocation rearrangement. All right, here's another example, right? When I have protons being stolen by things, right, this is proton transfer. Okay, we can do the same thing for multi-step mechanisms. Don't get overwhelmed by all the steps, right? Just focus on one step at a time. So what happens when I go from here to here, right? And in this case, this compound is losing a hydrogen, right? The hydrogen is being transferred to this base. So this first step is proton transfer. In this second step, right, essentially I'm adding a bond from here to here, right? I have a negative charge and a lone pair. This is a nucleophile. It's attacking the partially positive charge on this carbon atom. This is the electrophile. So I have a nucleophile forming a bond with an electrophile. This is nucleophilic attack. All right, and then in the last step, right, I've got a hydrogen being transferred from the water to our compound, and so this is an example of proton transfer. Okay, here's another example. So I'm starting out, right, I've got a base stealing hydrogen. This first step is proton transfer. Then in the next step, right, I'm going from, we've got a chlorine, we don't have a chlorine, right, I've lost a chlorine, so this next step is the loss of a leaving group. All right, now I'm forming a bond. I've got a negative charge and a lone pair forming a bond with a carbon atom. This is an example of nucleophilic attack. And then we're fissioning it off. Our compound is stealing a hydrogen from water, so this last step is proton transfer. Okay, the other thing we might be asked to do is to draw in the curved arrows that accomplish the transformation in the mechanism. And so we want to draw the arrows that get me from here to here. And I think it's a good idea to go ahead and put in the lone pairs. So missing some lone pairs on the bromines and the chlorines. All right, so in this case, we're forming a bond between the chlorine and the carbon. So that's going to be a nucleophilic attack. So to form that bond, my arrow needs to start on the lone pair on the chlorine. Right, it's going to point to the atom that's forming a bond with. And this bromine is popping off. And I've got to, right, if I just had this one arrow, I'd be violating the octet rule. And so to not violate the octet rule and to pop this bromine off, we're going to take this bond, and it's going to become a lone pair on the bromine. All right, here's another example. Again, before I even start, I'm going to go ahead and put in my lone pairs. All right, so we've got a couple things going on here. This negatively charged oxygen. It's becoming ROH, so it's stealing this hydrogen. And then the chlorine atom is popping off, and I'm getting a double bond. Right? So let's kind of tackle each one of these kind of individually. Right? So first, let's have the oxygen steal the hydrogen. So one of the lone pairs from the oxygen is going to steal that hydrogen. Now, this bond has to go somewhere, right? So I think it becomes the double bond here. So we would have that arrow, and then the chlorine is popping off. So the bond here becomes a lone pair on the chlorine. Okay, so now we have a multi-step mechanism, and we want to draw the curved arrows for each step. Don't let this whole mechanism intimidate you, right? Just break it down into individual steps, right? We have just a bunch of one-step reactions that we're chaining together. So I'm first going to focus on this first step, this first little reaction. And so I'm transferring a hydrogen from the hydronium ion to our compound. So the lone pair on our nitrogen is going to attack one of the hydrogens from the hydronium. Right, that bond will become a lone pair and it becomes the water. I think I mentioned earlier in this video, right, sometimes when we have reactions with hydronium ion and water and hydroxide, sometimes we don't care what happens to the water, the hydronium, or the hydroxide, and so we don't write it with the products, and so we're just focusing on our main compound. But we still do want to draw the arrows to show what's going on. All right, now we're going to add a water to our compound. So we have the lone pair on the oxygen, we've got some nucleophilic attack going on, and then the nitrogen is picking up a lone pair, so this pi bond is moving on to the nitrogen. So lone pair from the water, pi bond moves on to the nitrogen. All right, now we're focusing on this step, right? And so what's happening is this compound is losing an H+, right? The water is stealing that H+. So arrow goes from a lone pair on the oxygen to the hydrogen. That bond becomes a lone pair on our oxygen, right? And we're going to be forming hydronium, but we don't really care what happens to it, right? So we're just focusing on our main product. Okay, now we're going from here to here, right? And what's going on is the hydronium is going to be protonating our nitrogen. So the lone pair on our nitrogen steals that hydrogen, lone pair goes on to the oxygen. All right, now we're focusing on this step, right? Essentially, we're breaking this bond here and opening up our ring. So this is basically an example of losing a leaving group. And so the nitrogen is picking up a lone pair. So the bond that we're breaking, those electrons are going on to the nitrogen. If we see oxygen is picking up a double bond, so one of the lone pairs is moving down. So bond goes on to the nitrogen. Lone pair goes down to form a double bond. All right, our last step we have here. Right, and I think the only thing that's happening is we're losing this H+ being stolen by this water. So lone pair steals the hydrogen. The bond becomes a lone pair on the oxygen.